Hey guys, how you doing? Steve Lav here. On this video here, I'm going to talk about oil-fired boiler controls, aquastats, and there's certain ways to wire things. And the reason why I'm doing this video is I got called in to do a job for this guy. He basically had a shower valve all apart and called me in. He couldn't get the seats out and stuff, and he was, a couple of towns over, so he called me if I could go fix his shower valve. He had no hot water. So I went in there. I was able to take all the seats out and rebuild the shower. He had all the parts. So I had no problem with that. And then I got the shower valve back on. He was working on it like, all day type of thing. And he got jammed up. He couldn't do it. So he called me in and I fixed it. And I got the shower back on. I says, well, I turn the water on. Let's check it and make sure that fixed the problem. Because when I got there, everything was apart. So, he go and turned the water on, and I turned the shower on. The water was coming out hot and everything. And I says, what was the deal? Why did you take it all apart? He says, well, I keep losing my hot water all the time, and it can't be the heating system because so and so just put a brand new heating system in downstairs, oil-fired boiler with a brand new system. So I said, all right, that's fine. Let's run the hot water for all. Make sure you don't lose the hot water before I leave. So I did that. I checked it, and it was kind of like a little bit on the fence. It wasn't really hot, and he brought his wife over, and she was complaining, well, ever since the new system's been put in, we've been losing hot water, this and that. I says, all right, well, let me go down and let's check what's going on. So I went down there, the guy had a brand new system in there, brand new oil-fired boiler with 2 zones, and it was a beautiful job. The guy did a good job. I know who installed it. The guy's been, doing oil burner work for like 35 years, and I know the guy. I see him at the supply house all the time. He seemed like a real good guy. I think he does decent work, good work. He's got his kids working for him and everything, and I respect the guy. So I went over there and I turned the tempering valve up because it was kind of low. Usually when I do a boiler job like that, I'll put the tempering valve on like half. So I put the tempering valve on half, and I noticed he didn't have a shut off on a cold water feed going into the little Warts tempering valve. But anyway, I went upstairs and we ran the water, and it seemed to be okay. And all of a sudden, we lost the water. Boom! It started going cold on us right away. So I said, "Oh, something's up." So I went down there. I said, "Let me look at the controls and how it's wired." So I told her, I said, "Go upstairs and turn both heating zones on, okay? And we'll run the tankless and we'll see if we drop down below the 160. It should maintain 160. It shouldn't go below 160 if it's wired right. I don't know how it's wired. I didn't start taking all the wiring apart and look." So she put both thermostats up. You know Turned the shower on, went downstairs. We watched the temperature gauge on the front of the boiler. She dropped right down to 120. So I said, obviously, he doesn't have the reverse hooked up on that secondary zone control he put on. He had 2 circulators. He had another zone control separate. And this video is dedicated to showing you how to wire it so this don't happen. Now, I told the lady, I said, listen, I ain't stealing the guy's customer. I know he's a good guy. Call him back. He'll fix it. So I said, if he's got any questions, have him give me a call on the phone. So he called me on the phone all bum hurt. I've been doing it for 35 years. So I explained to him what was going on. I said, you didn't wire the secondary zone control through ZZ and ZR. That drops out on the low limit. That's what them ports are in there for extra zone controls. So he got all pissed off at me, and I told the homeowner right up. I said, listen, the guy's a good guy, maybe his electrician didn't wire it right. Come to find out, he's been doing his own wiring. I don't know. But anyway, I told the lady, I says, he'll straighten it out. He's got to straighten it out. It's a brand new system, Can't be losing hot water every time she's in the shower and the heat comes on, you lose your flipping hot water. That ain't no good. So this video is going to be dedicated to showing you guys how to wire it properly. Help out the young guys. I didn't know this when I was starting out. I learned it as I went along the hard way. So that's why I do these videos, to help out the young up and coming guys. And maybe you won't make the same mistake this guy did, or I did when I first started. All right. Hopefully you enjoy the video. Guys, I don't know if you can see these controls or not, but I'm going to do a little video on oil burner controls. I've had some questions been asked me, and I've had a couple of guys that didn't know what a couple of these ports were for.
I'll try to explain to you in detail. This is for an oil burner. You could have it for gas or oil, but this one is for oil. You've got a high and a low limit. The low limit would be strictly for if you had a tankless heater or you want to maintain boiler temperature, which a lot of oil boilers will have a tankless heater for domestic water, and you'd have to have a low setting. This has got the high and the low. This type of control here, which this one I believe is for an oil boiler, it is strictly high limit. You can tell by the control here. You can tell it's strictly high limit. Then you also have the same kind of control for gas. This is an older style one for gas. The new style ones would have the Molex plug for the vent damper, but this one don't have it. What I want to go over with this control is, if you look down here, you got a B1, B2 terminal. I don't know if you guys can see this, if it's too much of a glare from the sun, but it's got a B1, B2 terminal. It's got a C1, C2 terminal. The B1, B2 is for the burner. C1, C2 is for the circulator. Then there's a ZR and a ZZ control. And I'm going to explain to you what the ZR and the ZZ tapping is for in this control. Now, what happens with the C1, C2 terminal with this control, it works off the low limit. In other words, the boiler has to maintain whatever the low limit is. The boiler doesn't want to get any colder than what the low limit set at. The low limit set at 160 to maintain domestic hot water in the boiler. So at 160, anything below 160, circulator C1 and C2 will lose its power until, you know, we get above the 160, and then it'll send power to the circulator. The reason being is, if you're calling for heat and domestic hot water at the same time, if this thing wasn't on the reverse, the circulator would pull the boiler temperature down below the 160. So that's what they call a reverse in the control that this is wired to. Now, the problem guys run into is they have a boiler, okay, with a tankless heater, and they add another zone, or 2 or 3 zones with different circulators. Now, if you go one circulator and zone valve, that's not a problem. But if you got two zones with 2 separate circulators, they add a zone control on the side here. Now, if they don't wire it properly, this other zone control is not hooked up to the reverse or the low limit. So I'm going to explain to you what that port, what them tappings ZR and ZC do. Okay? ZC is hooked up to the reverse that would send power to a zone control. ZC. That would send power to the zone control. Okay? So when this got to low limit, which is 160, you'd shut power off to the other circulator to maintain domestic hot water, to maintain temperature in the boiler for domestic hot water, for the tankless. Very important. Now, ZR, okay, what you do is you send power from ZZ to the control, and then back to ZR, which is run. ZR will fire the boiler up to high limit. Okay, so the ZC is to feed the control with power that will drop out at the low limit, and the ZR, just remember, ZR just would be for run. That would fire the boiler back up to high limit. Now, if you don't wire it through them 2 controls, them two ports, this other zone control will work, but it's not going to work properly. It's not going to shut off on a low limit, and it's not going to fire the boiler. If you're just feeding it a 110 leg down to it, you know, it'll work fine. But it's not gonna fire the boiler, or it's not gonna be hooked up to the low limit. So that's the proper way. That's what them ports are for. Them tappings. ZR is to fire the boiler up to high limit, and the ZC is to feed the zone control, and it'll drop the power out at the low limit setting. It's pretty basic, but a lot of guys don't know this. And you only find that ZC and ZR on a boiler control that maintains low and high temperature. On a control like this, it won't be on it. is a strictly high limit. You don't have a low limit, you don't need it. Okay? Basically, more or less, the only thing you're going to see a tankless heater on, tankless coil in a boiler will be an oil-fired boiler. There are also some old gas boilers that had the low-high control that also had tanklesses in them, but very rare. Now, another thing, if you wanted to delete this low temperature limit, you could turn this into a high limit control only by taking this red wire and this white wire right here. You see this little punch out, you could push a little screwdriver in there and release it. Tie them, the red and the white wire together, they'll turn it into a high limit control. There'll be no more low limit, and they'll do away with the low limit side. If you tie the white and the red, you can see where it's got little push ports. See them little push ports? You put a little screwdriver in there and you can pull that wire out. Same thing with the white one up top there. It's behind this blue here. This is the high limit part right here. Whenever you do something like that, it's always good to check the control, make sure the control's working. But I have done that in the past, and that will work. The red and the white wire deletes that low limit control. A lot of times we'll do if we turn this into a cold start boiler, we'll just turn this right down to 110. If you're not maintaining temperature, so the boiler don't stay hot all summer. With a control like this, if you got this at 160, in the summertime, this is going to maintain 160 degree temperature. So, if it's a cold start and you don't need to maintain that temperature, you could drop this down, do what you want. This is a good control if you have a cold start boiler. It's got a real high volume water count, and it's condensating and it's turning all to white soot inside the boiler. Put a control like this and maintain, like 140 or something like that, or 150, and the boiler water coming back, as soon as it gets to that temperature, shut the circulator off. To maintain it. If you don't have a bypass, you could use a control like this, and that would help that situation out. But this control is going to run all summer. It's going to maintain that boiler temperature. Whatever the low limit set at is going to maintain that temperature year round. So that's what them other tappings do. They're tied into the reverse part of this control. So hopefully that helps some people. Educational videos. Alright guys, I'm going to go over this control with you that I was talking about outside here. I got this as a wiring diagram that I had, that I blew it up on my copy machine, and I'll go over a couple of details here with you, how it should be wired according to the wiring diagram. Okay, so we got a triple actin aquastat, which has a low limit and high limit. It is a Honeywell L8124A or C. Now, the only difference is one would be a vertical control and one would be a horizontal control. Same thing. Okay, it just depends on which one you need. What we have here is we've got the L1, L2 coming in from the switch on the side of the boiler, which is the power feed coming in. Okay, so your power feed comes into this main aquastat that we're going to talk about right now. It comes in the L1, L2 would be the neutral. Okay, that would power up the low voltage, which is the thermostat, which runs up to your thermostat on the wall. And it would also come down and it would feed, through your high limit for your B1, which is burner, which is a 110 oil boiler, oil-fired boiler, which would be a 110 feed. And it also would feed the circulator. Now, how this thing is wired, you got a low limit and you got a high limit. Okay, this particular control that has a low limit will maintain boiler temperature for a tankless water heater. It's got to maintain 160 degree boiler temperature, so when it calls for domestic hot water through the tankless, it's hot enough to heat the water up for your showers and your hot water. So this is what this control with the ZC is basically designed for, to maintain boiler temperature, whatever you want to set at, 140, 160, whatever you want to do. If you need to maintain boiler temperatures, is the type of control you need to use. Okay, so I'm going to try to explain to you how it should be wired. This is an additional zone relay. If you have, say, 2 or 3 circulators, 2 or 3 zones, with this, if you have separate circulators, you need a zone control. Now they make Takeo zone controls, 1, 2, 3, 4 zone controls, whatever, all in one package. Them are very nice. This is a single zone relay that I'm talking about here. With the other zone controls, you still have to wire it through the ZRZZ terminals anyway, and I'm going to explain that to you. Alright, so what would happen is if this boiler, a call for heat on this boiler, once the low limit is satisfied, it would send power to C1. The burner would fire anyway, but the C1 terminal, which is the power going to the circulator, would not come on. It's off on reverse if this low limit is not satisfied. See it right here? It's off on reverse. That low limit is not satisfied. C1 will not work. The reason being is if this circulator is running and the boiler temperature is at 160, the circulator drops that boiler temperature down to 120 or whatever you want. It has to maintain 160. So it's called a reverse. Okay? And this ZC is also on that low limit circuit, which is also on the reverse. Okay? The CR power coming back will fire the boiler up to high limit and shut off on high limit. Okay, so we got the B1, B2, which the low limit will fire up B1, B2. This low voltage thermostat pulls in, it's going to fire up B1, B2. The only thing B1, B2 is hooked to is the high limit. Okay, so the low limit is hooked to the circulator circuit, C1. So now let's look at the ZR-ZC terminals. Okay, so this is basically on the same leg as the circulator terminal. So if you feed this additional relay, the second relay for the second circulator through ZC to the number 1 terminal, okay, when the boiler is below the 160, the low limit is going to shut this zone control off. Dump the feed to this zone control, and it's gonna obviously if there's no power going to that control, the low voltage, it's not gonna work. The transformer's dropped out, so this circulator will not run, and this is additional zone control if this boiler is below 160. And that's the idea of this video, to maintain boiler temperature. You have to wire things through these two controls on additional zone relays. Okay, now the way they have this wired is they got the L1 coming in to feed L1, L2 on the zone control, the neutral and the L1 through the switch, through your boiler switch, through your high limit and whatnot. This is the main power coming in, and they also feed L1, L2 directly to number 3, and 5 terminals. These are dry contacts. They're gonna, if you feed power to this, they're not gonna engage. They're normally open. Okay, so they got 110 power coming into number 3 and 5 at all times. Until this thermostat calls, okay, these are not gonna go through their circuits. So if you drop number 1 leg out, which drops this transformer out, this thing isn't gonna make until this power gets reintroduced to liven up the transformer. This is a step down transformer right here. Okay, so we got power coming into 3 and 5 the way they have this wired continuously. When this zone control is maintained, it's above 160, we got power coming in here. This second floor thermostat calls, okay, pulls these 2 relays in. Number 3 goes to 4 and goes over and fires the boiler up. So obviously, when we run the circulator, we want to run the boiler up to high limit so we get as much hot water as we can. If you don't have this hooked up, it's only going to run at the 160 degree temperature. We want it to fire the boiler up to the 180 and shut off on high limit to heat this up faster. Okay, so 3 goes to 4 to fire the boiler. Now 5 goes to 6 to run the circulator. When the zone valve calls, fires the boiler, runs the circulator, heats the second floor up. When this zone valve gets hot enough, it's satisfied, okay, we shut off. These contacts open, these 2 contacts open. We got power coming into the transformer, ready to rock and roll at any time, as long as we're above the 160. Now, another thing I talked about on my other video is if you wanted to turn this into a high limit only, you could do away with the low limit on this control by tying red and white together. But you would lose this ZC terminal if you did that. Okay, this wouldn't drop out anymore. You wouldn't have this. So if you wanted to use this control strictly high limit, you only had one, you had high limit, you had no tankless, you weren't concerned about the low limit control, you could do that, but you're going to lose this ZC terminal. Okay? The boiler, you could still fire the boiler, but you would lose this reverse action. I did mention that as something that could be done, and I just put it out there. Alright, so I'm going to leave this little picture up for you guys, and you can see how it's wired. These are just dry contacts. Now you could also come here and feed this one. You could feed 3 and 5 through 1. I've seen that happen a lot of times, but this is the way this diagram's made. You could have constant power to 3 and 5, because that's not going to make until this energizes. So if you drop this out, that's not going to make anyway. That's just how they got it wired. And this is what you call a schematic. Little wiring diagram. This is the low voltage side. So hopefully it helps out some of the young guys, and maybe some of the older guys that didn't know about these two terminals, what they do, what they're there for. It's pretty straightforward. Alright guys, thanks for watching. Ready to go out, huh? Got the little tail going, got the little tail going there. It's the baby dog, man. What a potato chip. What the? They're doing the skid marks. Alright, come on. The baby dog doing a little doggy dance. Oh yeah, there's the doggy dance. There it is. There's the little doggy dance. Oh yeah. Get her a little coat and be putting it on there with a scarf later and go out.